Hi, this is Pooja Kalra, and the project that I'll be talking today is an implementation of an end-to-end data pipeline for an e-commerce platform. This is a high-level architecture. This architecture is designed to ingest transactional inventory and marketing data from multiple operational systems and transform it into the Lakehouse for analytics, reporting, and data mining. So the source systems includes an order management system that has data for customer, products, orders, payment data, and or an inventory system that to send the daily inventory snapshots, and the marketing advertising platforms to provide the campaign data. So first this data lands into the landing zone in AWS S3 bucket, and from there gets transformed using Spark with the power of a Delta Lake and stored as a Delta tables in S3 bucket. Then we are generating Symlink manifest files for Athena service to use them to make it available for reporting ad hoc queries. So here next one we have is this Delta Lakehouse Delta Pipeline architecture. So this is a logical data architecture of this pipeline, and this focuses on the data flow, processing layers, and control mechanism. Here we have divided the Lakehouse into three layers: bronze, silver, and gold. This basically is to ensure the fault tolerance, because say suppose any stage fails, say silver fails, so in that case we don't need to run the whole pipeline from the start, but what we can do, we can just run the specific silver stage again and load the data. All these three tables have their separate processes, separate by the Delta Lake in S3. So what happens here, the source file, they first drop to AWS data lake, and then bronze layer will come into the picture that reads the data from these ingested files and stores them into the Delta tables in append mode, depending upon if it is an incremental load, or for the first time, if it is a first time full load, then it's an overwrite mode. Then comes the silver layer. It only reads the incremental data from the bronze tables and it writes in the Delta table in overwrite mode always. And here we are doing the transformations and the cleaning of the data. And then comes the gold layer. It reads the data from the silver tables and do upserts. So depending upon the data, it do insert, update, depending upon if it is SCD1, SCD2, or the fact tables, does the joining and all. Then comes a load controller table. So with this table we have created just to load the history to decide if the load has to be full or incremental. I'll be covering the rest in the next video. Hi, so here I'll be talking about the data dictionary. So these are the dimension tables that I have created. The first one, like the channel. So channel basically, if it is marketplace like Amazon, eBay, or if it is a retail, the actual shop, or if it is a wholesale B2B, or like if it is a direct to customer, like our own websites. So, and another one is the store. The store is the real store names, like if it is an Amazon India, Amazon USA, Amazon Canada, Mexico, or eBay Global. If it is a own shop, right, retail, which branch it is in Delhi, then retail Delhi. And then if it is your own brand website, it's a brand website. And then comes the currency. So which marketplace dealing with which currency, like Indian rupee, or US dollar, Canadian dollar, Japanese yen, Korean won, Mexican peso, and all. And then we have this date. This one, we have a function that generates the date. In this function we are taking the start date and the number of years we want to generate, so accordingly it will generate the date in this form. We are having is weekend. I have not added the fiscal year, quarter and month, but I have added it here. It's optional. If your project or it basically deals with this kind of data, then we can have it. For me, I have just removed the fiscal years and all, and just done with these columns. And then we have the dim customer. So the customer details is coming in the customer feed file, and the same feed file is having the customer details along with the address of the customer. But I have divided, for the simplicity, I have divided it into two tables, dim customer and dim customer address. Both dim customer and dim customer addresses are SCD2 because we want to retain the history. And the customer will be having a general details about the customer, like what is the customer name and their gender, date of birth, and when they are starting, if it is like active or not, like if it is current or not and all. And the business key here is the customer ID per store per channel. And I have saved it as a hashed in a big int. And then we have the customer address that has the address details, and again SCD2. And here then we have the product also coming as one feed, the product feed. We have divided into the product and product price to make it more simpler, because product I'm keeping it as a SCD1 because it is not changing data. And the product price is it is SCD2. So that's the purpose I have made it two different tables. And then we have the fact tables. The first one is the fact order. That one having a grain of one product within an order. So say suppose our order is having two products, and there will be two lines, separate record lines will be here. One order, like order 001 with order 001 with the line number 1 and product ID 1, and then order number again 001 with the line number 2 with product ID 2. So an order may have the multiple rows. So and then next one we have here is the fact payments. The green here is the one payment transaction for a complete order, not the per line of the order, but for a complete order will be having one payment transaction as a one row. And then we have fact inventory. This is a snapshot of each product per store per channel for that particular day. So every day we are receiving inventory snapshot for that product from channel per store. And then we have the fact ads performance. Fact ad performance table basically coming from the marketing platform about the campaign for that day, for that channel and that store. And the last one is we have fact customer events. So this is basically holding the event per product. So basically what customer doing on that product. So what is the event type? Is it search? It is add to cart, and this is a schema evolution. So this is coming as a JSON file, and with the schema evolution. With that said, if the event type is add to cart, then we'll be having a payment method. So accordingly, what we have in event type, it will basically evolve accordingly. And this is the table. These are the tables. And then we have I am representing this as a bus matrix, because as we have seen in that sheet, that multiple facts are connected, are related to the shared dimensions. So this is more cleaner and readable way to show it, to represent it as. So I'm representing it as a bus matrix. Then I have individual star schemas for the fact tables. The first one we have is the fact order. So fact order connected with the customer, product, for that channel and store, with which currency the data coming from, and the shipment date and all. So this is a star schema for fact order. And then we have for the payments. So payment is again the star schema with the customer, per store, per channel, what's currency, and that payment date. And then we have another one is the inventory star schema. So it is coming as an inventory. It is related to the product ID, and for which store, which channel, which currency, and which date that inventory belongs to. And then we have the customer event star schema. It's depending upon what customer and which product. And customer is related to channel and store, because customer will be different for per channel, per store. We have these. This is a business key, so we are maintaining it like this. And then we have the ads performance for the campaigns. So this one is related to the store, channel, and currency, and the date, for which date we are taking like a ad date, which ad date this campaign was for, which store, which channel. So this is about this. And yeah, this is all done. Then I'll show you the AWS that I have ready here. So I have created this bucket, and then I have created this folder, and then I have created an archive, landing, and the warehouse. The landing where the file will come from the source, and then the archive, when it is read in the landing, then it will be archiving it to archive folder. And the warehouse will have the bronze, silver, and gold tables accordingly. And the landing, I want to show, I have made multiple folders including customer. The customer file will be coming here, and inventory, order, payment, product, and the similar structure I have made it in the archive, so they'll go to their respective places. So right now we don't have any data in here. Just want to show. Here, and in landing I have already kept the files. So customer events will be the JSON file, and the others will be the CSV. The customer will be the CSV file, and then the campaign files, and inventory, the snapshots, and the fact orders, payments, and then the product feed. So this is all about the AWS. So here I have my Jupyter working on running on Docker, and here these are the modules. So I'll just go first with the utilities. So we have a general Spark session we have created so that other modules can directly import it. And then we have a load controller. So load controller basically is to insert the control logs in the load controller. And so what here we are getting, we have a layer in the load controller table. We have a layer that could be bronze, silver, gold, and then the schema name and the table name for which we want to load the records. And then the load type is basically if it is incremental load or if it is a full load. And then we have a write mode that could be append or overwrite. And then load timestamp when it is being loaded, status if it is failed or success, and the loaded count, and created by and modified by. So load timestamp, here we are changing it to timestamp, and then created and modified on are not coming in this data. So we are just adding them with the current timestamp, writing it in a append mode into the delta table, and load controller is has created in the as a delta table. The second one we have is the get maximum load timestamp. So this function basically used by all the layers, by all the modules in each layer, to check if it has to be full load or the incremental load. So what this function is doing, it is reading from the load controller and checking if that schema and the table name is there. If it is there, it will getting the maximum load timestamp. If the maximum load timestamp is there, it is sending it. Otherwise, it is just returning the default date of 1900-0101. Next one is delete control log. If we want full load later, so we want to delete all the entries from the load controller for that schema and table. So this function is for that. And truncate control log is basically to delete all the rows, basically undo the load controller totally. And so for this one, we have to set the retention duration check enable to be false for it to be vacuumed. And vacuum, basically we are deleting, removing all the history of the delta table. So the next one we have here, we are doing the DQ checks, the data quality checks. For this we have defined the multiple checks for all the fact tables, including fact orders, fact payments, fact inventory. So these ones are the conditions. Order ID is null. I'm just giving you an example for this one, like order ID is null. The first one is the condition, and the second one is the error description, and the third one shows if it is an error or a warning. So similarly we have defined it for different fact tables. And what we are doing, if the no table is if there are no mappings defined for that table, then we'll just simply return the no DQ checks defined for that particular table. Otherwise it is checking what the data frame that we are passing. It is checking if the where condition, if it holds these condition like these ones. Okay, so say suppose I'm getting a product price as a table. Okay, so for the product price I'll be checking checks dim product price, this one. So I'll be checking all the conditions of check dim product price for product price table. And this one, if there is a warning or error, we'll be first logging it into log DQ checks. Log DQ checks is in the DQ logging. It is basically storing the error in that DQ results table with a table name, what is the condition that it was failed with, error message that it was failed with, and the failed count, how many condition, how many rows have been failed, and then error type, and then source file. And error type, basically if it is a warning or a error. So this is basically adding it into the DQ results table. Other than that, what we have done is we don't want it to, like if the error is coming, we don't want it to stop working. So instead what we want is to store that record in the bat table instead if it is a error. So other than that, in DQ checks, what we wanted, like if it is a error, not a warning, then we don't want to stop the working of this, and should not want to get like the hardcode error and like stop the working. So instead what we want to store the error data into the bat table for that particular table. So we have already created these bat tables. So say suppose if it is a fact customer event, the bat table will be bad underscore fact customer events that we have made. After that, once if there are any error condition, then we have to change the data frame, basically by removing all the error and the join conditions, so that the valid data frame can be returned to the layer back, to the module back, and so that it can be appended or inserted. So the next one we have is the S3 AWS. So that one we have made for the archive, to archive the files that are coming in the landing zone after the reading is completed. So this one will be called from the bronze layer for each module. For all the basically the files. So what it is doing, it is basically creating a bottle client for the S3, and it is basically copying from this bucket e-commerce ninja that I have shown that we have created, and it is going to that so this one is for the landing. So from where basically this is a target and this is for the source. So this is a target, and for the source we have a bucket and with the key of that landing folder. And then if the response we are getting is 200, what we'll be doing, we'll be deleting that object in the landing in the S3. If we are having any, if we get any error exception, we'll just throw this error while like error while archiving the objects from landing. Other than that, we have this I have created this utilities. What this utility is doing, it is having a generate date. So this is for the dim date, that there is a dimension date table that we are using for the ship date, purchase date, payment date and everything. So here we are generating the dates. The start date will be coming in and the number of years it will coming in. By default I have set it to 2025 1 and the year is 1. So this is just to create those dates, and after that I'll show you the bronze layer. So we have divided, before that there is a one initial scripts. So this DML dim channel, so channel for the dim channel, dim currency and dim store, we are basically having a data inits, and for the dim date that will be generated as I show you from that utilities generate date, and the init db is basically to create the database. uh, if it is not exist, bronze, silver, gold and bad, it will be created under the warehouse folder in the S3. And this is basically to create all the gold tables for customer and customer address and all of them. And then we are creating, once it is created, then we are having the bad table, belt tables, and they are using delta. So all are delta tables, and after that we have a load controller table that we are creating, and the common DQ results we are creating. Once it is done, so I'll show you running these, and after that we have this channel, dim channel. Basically it is inserting, it is a simply data in it, it is inserting into dim channel all these inserts directly. And then similarly we have it for currency. The currency could be USD, INR, Canadian, Japanese yen, Korean won and all. And then we have stores. This is a data in it for the store: Amazon India, Amazon US, Canada, Mexican, eBay Global and retail and all. So, and the dim date. So first we'll start with initializing the database. So here we are creating a database, and then gold tables for gold schema, and the bad tables at the load controller, and the DQ error table. So here it is taking the function get spark function from the spark session utility that we have created to start the spark session. So here, so this is my S3 bucket. So here if I see the warehouse, right now we don't have any folders here. So if we go back to our here and we Jupyter and we create the databases, So it will show all the databases are created, and if I go back here and see, all the database folders are here, created here. Then I'll go back and I'll be creating the tables. First we'll be creating all the goal tables, and then we'll be creating the bad tables where the DQ error will be saved. So it has started creating tables like dim customer created, dim customer address created. Now all the dimension tables have been created. Now the fact tables are getting created. Now all our fact tables are also got created. Now let's move to table creation for the bad table for the bad records. And then this is the table for the load controller to save to load basically history, like history of the loading, to basically know if it gonna be incremental load or the full load. Okay, and the next one will be our DQ result, where all the error and the warning records will be saved for any DQ errors, irrespective of the module. And now we'll see what all tables got created in gold and what all tables created in bad, and stop the Spark session. Okay, next one that we have is the dim channel. So this is a data init for the dim channel table. So this is a dimension table. So it will read the table dim channel. If there are no records, so it will insert. Otherwise, it will just give us rows already exist. And this one is to read from the dim channel to see how many records have been inserted, and this is to check this. Okay, and this is to read from dim channel. So these rows are inserted, and this is to check from the delta history for the latest version. As limit is 1, latest version, how many number of rows are impacted. So it will show 4. And similarly, next we have the currency dim table, dimension table currency in gold. So that is also a data init, where it will first read from the dim currency table. If there are no records, it will insert. Otherwise, it will say rows already exist. And rows are inserted. Then we'll check from the dim currency table, and here the DT history, and also we can show like where these tables are getting stored. So they are stored to is an S3, so can check for the dim currency. So it shows it is going to S3 location, and so Spark, okay, and then we have another dimension table store. So this is also similar way, we are checking it from the dimension store. If it is there, then it will say rows already exist, otherwise the rows will be inserted. And then it says rows inserted, then we are checking how many rows inserted, and then let's see it from the history, the 7 rows inserted. Okay, and the last one we have for here in the init folder is the dim date. So this is basically to insert the dates here. It will be calling, we have a start date of 2025-01-01, and we are taking it for the we are generating it for 1 year, so 365 days will be generated. It will be calling generate date from the utilities, and it will be passing start date and number of years, and the date will be coming in this format: date, year, quarter, month, and all 365 days will be inserted here. So let's do that. So it says rows entered 365 is a df count, and we are appending it. We are basically putting these audit columns, writing order columns also. So here, and it will check basically the load timestamp. It will take it from the load controller to check if it is a delta load or if it is a full load, if it is first time and all. So if it is first time, it will overwrite and write it as a full load. Otherwise it will basically take the last date, how much it has been entered, and then it will append it. And this is to check it from the golden date, if what all records have been entered. And this is so here it shows the data is written to the dim table and the load controller. So here is the data. Let's check it from the load controller, and here this is 365 is the loaded count. And let's check from the history, from the latest version, how many number of rows are impacted. So it says 365. So now as this is done, and all other dimension tables, channel, currency, and store are done, let's move to bronze layer for other dimension tables that are getting created with the feed file. So the first one we have the raw customer feed. So raw customer feed, basically this is having the data, general customer related data, their name, their date of birth, and phone number, gender, and everything. And along with that, they have this same file is having their address field also. So with this, we are feeding the same file to the raw customer feed. But once it is done, we'll be taking this delta table, and then we'll be feeding the address and the customer table, because we want to segregate the data uh, for the customer and for their addresses, and both address and the customer data table will be the SCD2, because we want to retain the history. So just for the simplicity, we are segregating the data in the two tables. So this is for the file load that is coming from the source system. So this one, we have the get spark session function that will be load from the utility function, and this is for the archive lending. Once the file will be coming to lending and read, and then they will be moved to archive in the S3. And this is AWS. This is in AWS. This one is right now the archive of the customer, and this is a lending of the customer. So this is a CSV file which is in lending zone. So I'll just get the Spark session. So I'll start the Spark session, and the table name will be bronze raw customer feed, and this will be shuffle partition 16. I'm setting it to shuffle partition 16 because this is less data and we don't need the default 200 partitions, 200 default shuffle partition for this. This is a CSV file. We'll be reading with a header. So header is a true, and then I'm appending it with the audit columns. And what it will do, it will basically load the maximum timestamp it was last loaded, and it will be coming from the load controller table. If this is a first time, then it will be coming as a 1900 default date, and it will go to the overwrite else mode. It will write in a overwrite mode as a and treat it as a full load. If this file was already loaded and the next day this file is coming again, so it will be loaded as a in the append mode as an incremental load. And then we'll go check the load controller table. So this says data returned to the raw customer feed and load controller, and this one, the 5 data came and it is success. And then we'll check it from the delta table history also, and it says, and now we will be going to archive this file because it has already been read. So it says the file is archived. We'll stop this part, and we'll go and check our landing zone. So there is now it has been moved, and let's check the archive customer and the file. The next one, once the raw customer feed is done, next one we have is the raw customer. So raw customer is basically reading it from the table. This is all done. The table will be bronze customer, and I'm again doing the shuffle partition of 16. We can do 8 also, that is also enough for this much data. And then I'm reading it from the table bronze raw customer feed that we created in our last video. And what it will be doing, it will be basically selecting only the related columns, basically not the address columns, and other than that all the general customer related columns, and it will dropping the duplicates in the file. This is not the deduplicated logic that we gonna do it in the cleaning during the transformation in the silver stage, but it is just the dropping duplicate. If say suppose in a file the duplicate data comes, so just don't feed it, just don't insert it into the simple bronze table itself. So that is just for that. And from there it will append these audit columns with it. So this is as it is, there is no transformations done on this data in the bronze layer. And next one we have is it will again read from the load controller table for the load timestamp, if it to know if it is a incremental load or if it is a full load. Once it is written, we'll just check the bronze table and the load controller table and the history, like how many rows were impacted for this. So data has been written to bronze customer, and the load controller, that is a bronze customer data, and that is a load controller data that has been loaded. And this is a DT history. It shows 5 rows were inserted. As we saw it with the customer feed, the 5 rows were there. And then simply we'll go to this raw customer is done, and then we'll go to raw customer address. And this will basically the same thing, just it will take the address related fields from the raw customer feed, and it will basically drop the duplicates related to if there are anything related to the address. So customer ID, stored channel, and with the effective start date. And then will be appended again, will be appending again the audit columns with this, the same concept of a full load, and identifying the full load and the incremental load. So this one, number of output rows, why it has been written 4, because let me show you the data. So the 4, so these are the 4 rows, but the customer was 5, right? The 5 rows. So the 2 rows are, I intentionally put the 2 rows as the duplicate rows in the file, just to show you that like we are deleting these duplicates from here. So this is the one, and here we have this files.
You're irritating me right now. You know that, right?
Why can't Bob come down? So here if you see this one, the address 001, so these two, address 001, 001, exactly same. So these were duplicates, so that's why we have removed it from the file itself, basically while loading the file itself. So that's why it is showing 1, 2, 3, and then one of these 4 rows so in the address table. And now I'll go to that S3 to show how it is showing here in the warehouse. If I'll go and I'll go to the bronze, and all these 3 tables have been loaded: raw customer feed, customer, and customer address. So here if you'll see, this has been loaded as a delta table. The delta logs are here, and this is a Parquet file that has been inserted here in the bronze DB for the customer, and similarly for other tables. Here. Now we'll go back to Jupyter. So all these are same because they are like a CSV, and this is bronze. We are just loading the data as is. So I'll just expedite the flow. The only difference is with the fact customer event, because that is a JSON. So I'll show you in detail how we are dealing with the JSON one. So next one, similarly we have product. Okay, so this says that raw product feed is not there, so I'm sorry, we have to first do this product feed, because I mistakenly did this product. First we have to do the feed because it is reading from the file. So, and then we'll go to product and product price, because it will be loading it from this product feed table. So this is a raw product feed. It is again the CSV header. So now this has been written there. We'll check 3 is there, and so this one is having this. So earlier it was wrongly written as a customer, so this is supposed to be product, because this is getting this folder name to check the file, and the file name supposed to be product, the folder name supposed to be product. So I'll try archiving the file again. So the file is archived, and then I'll stop the Spark, and okay, now let's try doing the raw product, as it was showing error earlier, because it needed raw product feed, and we had to first run that product feed. So now let's run this. This will read it from raw product feed. Now as the table is there, it will not show the error. It will be appended with the audit columns, and again it will check for the incremental load or the full load. So it was showing earlier the 3 records were added, so here also the 3 records have come here. The data written to bronze, and let's see the data from the table and the load controller. So 3 records added into this, and let's see the delta table history 0, and number of output rows are 3. So product is SCD1. It is just having all the product feed columns that are not changeable, so that's why we are keeping it SCD1. We are not retaining any history on that. And the next one we have is the product price. So product price is the SCD2, so that's why we segregated into 2 tables, one price, one product, and one price. So here we'll do it for the price. Again, it is reading from the raw product feed, and only the corresponding columns that are related to the price, and this is SCD2 table. And then we'll be appending with the audit columns and checking it for the full load or the incremental load. So data is written there. Three rows got written. Okay, the product price is also done. Before moving to other tables, I just want to show you this bronze TB. So customer address, and raw customer feed, product price, and raw product feed. These tables are already written to the bronze. And then we have here I'll go with the fact customer events. So this one is a JSON file coming in. Okay, so what it holds, it holds all the events of the customers, like if for the product, for example, like if we have a product view or add to cart or search or purchase attempt. So all these events are coming in, and we are doing the park merge schema as a true to ensure that it is basically taking the schema evolution in account, because say suppose if we have an event as a purchase attempt, then we have some other columns coming in like payment, credit card and all payment type. So in that case we need to make sure that our schema evolution is in place, and we are reading the proper rows depending upon the event types and other fields. So this one I'll start with here, simply getting the Spark session function and opening the Spark session, starting the Spark session, and then it will go to fact customer event. The shuffle partition 16 I have kept, and spark.sql park merge schema as a true. This is a JSON file, I'm reading it as a text, and a multi-line false because it is coming in a single line. I can show you the data, how it looks like. So okay, so this is a data that is coming, and just wanted to show that this product viewed is array field that is having like this array field, it is having the product ID and the category list of basically this combination of product ID and categories that customer have searched or a product viewed on. So this is like this, and then this is coming as a single line, so multi-line is false. And then we are appending the audit table, and then so it will be read as this here in the value column, as there is only one column there, and then appended with the audit columns, and then again it will basically see if it is a full load or an incremental load, depending upon if there is an entry in the load controller or not, and then it will be written to the table, and then we'll be checking what has been written to the load controller, and we'll see from the history of the delta table, and then we'll archive. So data has been written, and it shows the file has been archived. This is done. I'll show you how it is here. Here the fact customer event have been written. So this has been archived, and this has been gone from the landing. Then we have the fact set performance. This is the data coming as campaign data with the add date. This is the green is this is every day's data for that campaign per channel per store. So this one is also the CSV file, and this is going to fact adds performance. This is the same like we did earlier, format as a reading as a with the format of CSV with a header true, and dropping the duplicates if it is coming in a file, and then appending the audit columns, and then checking for the full load or the incremental load, and just saving and appending or overwriting depending upon the type of load in the delta table and the load controller table. And then after it is done, we are archiving the field from the landing to archiving folder in S3. So here the data is written to the bronze fact adds performance, and if you see, I just put one data here and number of output rows is 1, and then it has been archived and then stopped. Again, if you go here in the landing and fact adds performance, this data has gone, and if I come here in the archive, in the fact adds performance, the data now is here in the archive. And if you go to the warehouse in the bronze, and we'll see fact add performance and fact customer events are here. And if you go here, they have been saved as a delta table, so delta log is there with a parquet file, data parquet file. And then next move to the next one, the inventory. So inventory is basically a snapshot, the daily snapshot of a product per channel per store. So this is a snapshot, daily snapshot we are getting. So here this is again the CSV file, and this will go into bronze fact inventory. It is with the same concept what we are doing with other CSV tables, CSV files. As this one fact inventory is done, let's go to the fact orders. So this is the orders that we are getting, and this is per product. So one product is per line. So if in an order we have multiple products coming in, so it will be multiple line numbers for that order. So like order 001, one line number, one product, and for the second product, order 001, second line number, and then second product. So this is a fact order table, and this will be having the customer related details, which customer this order was, and how this person what this. Okay, so this is a fact order file. So this is order ID, line number, because one product can be one row equal to one order per product. So if order is having multiple product, it will be basically having two lines for that. So order ID line number 1, same order ID line number 2 for different products. So this is what it has, like which customer this order, which store, which channel this order came from, what was the product, and how many quantities and unit price, and everything that the customer have ordered. So let's start with that loading. This is again the CSV file. So we'll do the same loading what we are doing with others. So data is written to the fact orders. So there were two orders, 001, 002. So both of them are written here, and the file is archived. The last one we have is the fact payments. Payments is the one how the order was paid. Was it credit card and all. So let me show you the file for that. So here uh, so what was the order? So this is basically per full order. So if order is having multiple product IDs, so it is not per product line. So this is not per product, this is per full order. So if one order is having two products, so this is the complete order. So that is why this is a order ID, not the surrogated key we have used here. We have used the ID here, and then the customer ID for which customer this payment is for, and the payment date, store, which channel this has come from, and what is the payment method they have used, the currency, how much was the amount, and if it is if it was refunded or not, and if it yes, and then what was the refunded amount. So let's load this one. So this is going to the fact payments. Again, this is a CSV file. As I show in the file, there were two payments coming in. So it says, let me show you the warehouse also meanwhile. So all these tables are here. So, and this data written to the fact payments also. Let's check here. And then let's archive the file. File is archived, and stop the Spark. So here we are done with our bronze layer loading. So all of these are done. Now we'll start with the staging, where we'll be doing the transformation. That includes deduplication and formatting, and that will be basically adding the audit columns also, and some of our dimension table and other tables in the bronze need surrogate keys. So we'll be just making the hash surrogate keys. So now all the tables at the bronze layer is loaded. So now we'll move to the silver layer. So in silver layer, basically we are doing the transformation, the basic cleaning, where we'll be doing the deduplication, and then we are doing the data formatting to keep it with the same format as the gold table, and then we'll be doing the standardizing the codes. Say we have like types and codes that we want in a uppercase or lowercase, right? So we just want to make sure, like a channel and store. So if it is coming in a file, we want them to be in uppercase or lowercase. So for this project we are making it a uppercase, so something that what we are doing here. And then some of the dimension tables need the hashed surrogate keys. So we are also creating those surrogate keys, like in the customer table, in a customer address table. So we are doing that also. And then we'll be appending the audit columns, and then we'll be loading it in a overwrite mode. This will always be the truncate and the overwrite. For the bronze it is truncate and the overwrite, and it is always the incremental read. So first I'll show you how we are doing it. We'll start with the silver customer. So the table is the silver customer. So first what it is doing, it is basically taking the maximum load timestamp for the customer table in the silver schema. And what it will do, basically it will read the bronze table data. Only that data it will read that will be the latest to its maximum timestamp. So say suppose the silver customer was loaded yesterday, so the maximum timestamp will come for yesterday. And so the bronze table, if it was loaded today, so it will read the bronze table for all the records that have been created after yesterday. So that is the check that we have to make sure it is the incremental data that is coming in. And then after that we'll be doing the deduplicating. Here we have, for the customer, we have taken the customer ID, store channel, and effective start date as to remove the duplicate, as a business key to remove duplicates. So here we are using the row number. If this is like the same customer, store channel, effective date, duplicate is coming, then it will be row number will be 1, 2 and more, and we'll be just taking the first row number. And this is how we are deduplicating. And after deduplicating, so we have the formatting of the data. Say like I'll show you the schema. So all of them were coming in a string from the bronze table. So what we gonna do is we'll be formatting it as per what we need in the gold schema, the table, and it will be matching to the gold schema tables. So date of birth we need like YYY date format. So we'll be just doing the formatting accordingly. And similarly for the is current, we are just checking if it is coming as a true, so just make it as a boolean, because it is coming as a string. So we want just to want to make sure that it is going in as a boolean, and is deleted also going as a boolean, and effective start date as a to date. So we are basically formatting the data in this, and then standardizing the codes and types. So we have store channel, customer ID, that we always want whatever coming in the file, it should match everywhere, and it will have like the uppercase, right? So we are standardizing the codes and types here. Then we'll be adding the audit table, audit columns, created on, created by, modified on, modified by. And then this one shows that everything is fine now. The customer ID string, and date of birth is date, effective start date, date is current and is deleted made boolean. And then it will be writing always writing as a overwrite mode in a, so it is always writing as a overwrite in a delta table, and also it is inserting into the control log, inserting the control logs into the load controller, to make sure next time we can say, we can see when it was last loaded, to make sure that the data from which date it has to be fetched from the bronze table. So the data is written to the silver customer and load controller, and this one is the data. to show, and this has been written here. This is from the DT history, 5 rows inserted, and then Spark stop. The next one we have is the customer address. The table will be silver customer address, shuffle partition 16. Again, it will take the maximum load timestamp to know from which date we have to start picking the data from the bronze table, and then it is deduplicating based upon address ID, customer ID, store channel, effective date as a key, and then it is formatting the data and standardizing the codes, and then adding the audit columns, and then writing is over in the delta table as a override mode, and also writing in the load controller table. So the data started coming here, and let's see the gold controller. Okay, and then the DT history, 4 rows, because one was duplicate. I'll show you like last time in the bronze. So this is also done. Okay, and the next one we have is the ads performance. Okay, so this was all same because that was like simply just taking it from the bronze table and loading it. The only difference is in the fact customer event. I made it specifically as a JSON to show the difference in the loading, how the JSON we load, so that show the JSON transformations. That is little different. So, and yes, this is showing like what was the bronze table data count and what was the data count after deduplication. So let me show you this. Okay, and okay, and then again formatting the data. Here the cost and cost we are casting is as a decimal, and clicks and impressions we are casting them as int. So if we see here, meanwhile the warehouse, the data started loading here, and this is customer stored as a delta because delta log is here, and this is a Park data file. So fact its performance is done. Let's read it from the table, and then load controller, and then okay. So next one we have the fact customer events. So this was the JSON load. So this is little different in the transformations. So here we are doing the Parquet merge schema to make sure the schema evolution is in place, and basically schema evolution will be taken care of. And this is again reading the maximum load timestamp and then reading it from the bronze table for created on greater than that the last added data into the silver table. And then what it is doing, so this is a JSON, right? So earlier I show you like that was only the value column that was coming the data into, we read it as a text. So what we are reading, we are basically inferring the schema from the JSON data. So this is data, we are mapping it to the RDD row, and then the JSON will read the RDD row and for the scheme and will infer the schema from there. So this is for that, and then let me show what the schema will come out after reading the rows, after mapping it as a RDD rows. So the bronze table count 4, and this is a schema, and we know this is the product viewed will is the array type. So this one we have to explode and all the data we have to flatten. So let's start first the schema that has come. So we're gonna attach that schema with the value column and save it as an event data. So if I'll do that and here, so this is just the audit column that are coming, and this is event data. Okay, uh, so attached with the schema, so this one has come there, and then we are exploding the product viewed column because that is a array type, and we are extracting, we are flattening it with the product ID and the product category along with all other columns that are coming. So let's do that. It will show you event data and then product ID and product category. Okay, and then the event data, the other data in the event data column, we're gonna flatten it with the event and will extract out event ID, customer ID, channel, store, event type, and all other fields accordingly. Here if we see, this is product ID, product category that we exploded and flattened out, then event ID, customer ID, and all these fields we have just extracted. And then after this we are checking the we are checking the duplicate logic, and we are deduplicating, avoiding the duplicate rows and just taking the first row respect to that is created recently. So created on is descending, so we'll be keeping the recent data. So table count after deduplication is 7, and this is a data, and then we are formatting the data. Event timestamp has to be 2 timestamp, and then other standardizing the codes and types, we want them in upper trim so that they'll not be mismatched when we'll be doing basically joining in the gold layer. And then we are updating the created on, created by, and these audit column, because these were earlier also coming from, and now we want to from the bronze, but now we want to update it with the current one. So this is for that. And again it will write in a overwrite mode as a delta table, and also insert control logs into load controller for this run. And let's read the what has been in the table. So spark.read.table, it will read from this table, that is that gonna create silver fact customer. So here data written to fact customer event table, and then read the table. So this is the data that have been read here, and this one is from the load controller. And as I said earlier also, like if we say event type purchase attempt, then the payment method is coming as a credit card, and otherwise it is null. So it shows that the schema is evolved, so we are taking care of it properly. And then let's see the history and how many number of output rows impacted, and 7. Okay, now let's go to S3 and check if the table is loaded. And yes, so fact customer events is here and added as a delta table, as delta logs are here, and this is a Parquet file, the data Parquet file. And then after this, next one we have the silver fact inventory. And here this is an inventory snapshot. So let's close this and this one. So this will go in silver fact inventory, and again this will read the max load timestamp and deduplicating and formatting the data. So table count after deduplicating, both are matching. Standardizing the codes and types, and then adding the audit columns, and then writing in a delta table as an override mode, because this is always incremental load. So 6 rows are written here. And now let's move to the fact orders. This is again the same, taking the maximum load timestamp, checking, reading only those data from the bronze table that is greater than the latest timestamp, latest load that went in silver, and then deduplicating, formatting the data, standardizing the codes and type, adding audit columns, and then writing it as override mode. And meanwhile, let's check this. Sorry, silver db. Okay, so these this have been loaded here, fact orders. And then next one we have is the fact payments. Fact payments is about which customer from which store, which channel is paying for which product, and how the customer is paying, and if it is refunded, or if yes, if it is refunded, then what is the refunded amount. So this is what we are loading with this. We are cleaning that data. So here the payment date will be formatted to date, and then amount will be formatted to cast to decimal 18. It basically so this one we casted decimal 18 comma 2, so basically 2 points after decimal. And 18, and is refund is a true, is refund is a boolean, and then refund in amount again to a decimal. And this is standardizing the codes and types to upper, and then adding the audit columns, and then writing it as a override mode in the delta table. and writing it into the load controller table too. So data written to silver, fact payments, and load controller, and two data were written. Two records were written. Next one we have is the silver product and the silver price. So silver product, basically this is coming from the same file as we talked about, so we just segregated it because product was we want to keep the product as a SCD1 because there were no changes in the data of the product, product name and all, so it was not changing data, weight of the product and everything, but the product price, we wanted to we wanted to retain the history of the price, so we are keeping it as SCD2, so we just separated it from the product. And product is basically partition to check the duplicates. So product ID is the business key for this one. And here launch date will be changed to to date, discontinued date will be changed to to date, disdeleted will be changed to boolean. Here it will be written as a override mode in the delta table and also the load controller table, and we'll check the silver product. So this has been written here. Now let's check the load controller and the DT delta table history, and this is done. And the last one we have is the product price. So it will go to silver product price. It is removing the duplicate on product ID, stored channel, and effective start date. It is SCD2, so it's keeping the effective start date, and it's formatting the data, standardizing the codes, adding the audit columns, and then writing it as a override mode, always incremental load in the delta table and also in the load controller. So this is written here. So this shows this is the data from the table, this is from the load controller, this is the history that the 3 rows were updated, the 3 rows were inserted, impacted, and if you go here, this one, so these are 9 tables that are added in the silver layer. And now we'll go to the gold layer. So now we'll start our loading in the gold layer. So these are the tables that we already created with the initdb script, and also a couple of dimension tables. Those needed the data inits. We already did, like for the dim channel we already did, and similarly for dim currency we did it earlier. Customer address, customer, and everything, just the table is created, and the loading we will be doing now using Spark. And dim date was already done. We entered 365 for this year, the data for this year we entered into this table. And store was already done, it was a data init, and all other load controller is already being done, like with every module to save the control data, like to maintain the history of the loads. So all other that the remaining ones will be added now with the gold layer logic. So let's go back to Jupyter. So first we'll start with the gold customer. So what basically gold layer is doing here, so all the data that are there in the staging, they will come as is. The full basically full data will come first we'll take the all the data that is there in the staging, and then we'll be performing DQ checks, the data quality checks, and then the fact tables and dimension tables, they will be joined basically for the surrogate keys. And then we are having basic calculations, like we are deriving a couple of the columns in this, and then depending upon if it is SCD1 or SCD2 dimension tables, so we are doing upsert, and or if it is a fact table, and so how it is basically doing the merge. So it all depends upon that. So first we'll start with this gold customer. So this is simply getting the Spark session like we were doing earlier also, so I'll just skip this part. Table will be gold dim customer, and here it is reading from the silver table all the records. It will read from the silver table, and this is for the DQ validation. So what it is doing basically, this is nothing, it is just checking if the source file is there, because we need it for our DQ to put it as we are logging the source file name. So that's why we have just put this logic in place. If the source file name is not there, just put it as a unknown. And this is a DQ validate check that will be called. Okay, so this is DQ validate check that will be called, and it's here in the DQ checks Python script. Here DQ validate checks. So what we have done for all the different fact tables and dimension tables, we have explicitly mentioned what are the conditions that could fail, and if these conditions will fail, then what would be the error associated with those conditions. And then this one is telling if it is error or if it is warning. So this tells us that, like, if the gender is not null and this, so this is not a error, so we'll just treat it as a warning. And then after that it will log the error and warnings in the DQ result table, irrespective of so all the irrespective of the modules, all the data that will go in the DQ results, if they will fail with the error or a warning, and here with the failed count and all conditions and error messages will be logged in. After that, if it is error, then it will go to their corresponding bat tables also. Say suppose the fact order has been errored out, then it will go to fact order bat table. After we done with the checks, we'll see if there are any errors, like if there are really conditions like that has error, not the warning but with the errors in it. So what we'll do, we want to skip those, and because they have already been entered in the bat table, so we want to skip those. So we are just filtering it from our data frame, that was the original data frame. We'll be filtering those errored records, and we'll be returning back the filtered data frame with no errors. But here the warnings will still go as is and will be loaded into the tables. It will just the thing that warnings be logged in the DQ results, but it will not go to the bat table. So now coming back to the gold customer. So here if we check, and once the DQ validations are completed, we are basically so it says that I explicitly put record something like that to show the data quality check. And if we see here, the one record got failed because record cannot be deleted in current. So if I'll show you the data, okay, so here we have this thing. So here this data true and true, so it is not possible that is current is true and also this data is deleted. Okay, so this one we have taken as a DQ check, and I have inserted this data to show this case so that it will error out. And now if we go back here, so it says the same record cannot be deleted and current, and field count is 1. Now it would have been gone to the bad table of the dim customer, bad underscore dim customer. I'll show you that. So now apart from that, we were having so this is a warning, invalid gender value, and the field count were 5. Okay, and then table count after DQ validation is 4, because total 5 records were there, one is failed, to 4 will just not count the warnings, and will still be loading those data in here. And then we are creating a hashed business key and a surrogate key. The business key for the customer table is customer ID store channel, and surrogate key including the effective start date. And in here we are deriving the additional field like age. We are deriving it with the date of birth. Other than that, once the surrogate keys, business keys, and the derived logic is all done, then we'll be going and joining it with the dimension tables, and we'll be taking their surrogate keys to store it in the gold table. After that, if it is a full load, so this one is we are just getting the customer data from the gold table. Okay, and if the maximum load timestamp, so if it is a full load, it will come as a 1900 as a default date. In that case, we know that this needs to be a full load, so we'll be truncating the dim table, and for that truncating we are deleting it. And for that we need retention duration check enabled as a false, and we are vacuuming it to 0, so removing all the history of delta table also, so there cannot be time travel. And then we are merging on a logic, uh, like we have a condition. Let me show that condition. So say suppose in the table we already have this data. Okay, and is current is true. Okay, and now the file that is coming, right, the source that is coming is having a data of 7/1/2020. Okay, and as a true. Okay, we are not considering this is current that is coming from the source. uh, Okay, we are not considering this because anyways we'll be deriving based upon this effective date, which one is the latest, so we'll may mark it as a current anyways. So the first case is where this one will come. So we have a merge update on merge, where we are checking basically if the source table date that is coming is greater than what is there in the target table, means in the gold table already. If it is there, then we will be taking this date and subtracting one date prior, so 6/30/2020. We'll be updating end date here with 6/30/2020 and making it as false. And this one we have, so this one will be update on merge, and there is another merge condition. So what that merge condition will be doing, will be checking if there are no dates similar to 7/1/2020. So what it will do, it will basically merge on it will insert on merge these dates. Okay, and then the second case could come, say suppose there is no data in the table earlier, and in the source we are getting the history data also. So 1/1/2020. Okay, and again we are not considering this, okay, because it could be error in the file, so we just want to avoid it. So now in this case what it will do, again it will not go in the first update on merge because there is no data in the target. So it will go in the second merge again, where it will be basically checking that there are no data existing like this simply update insert on merge. Both of these will be coming here and inserting. Okay, but here we are also deriving this, so I'll tell you with another check the thing how we are deriving that. Now there is one more case, say suppose 1/1/2020. Okay, and now we have 1/1/2020, 7/1/2020, and then another one is coming with 8/1/2020. Okay, so now in this case we need to see, like, okay, which one is the leading of which one is the leading date of what, right? Depending upon that, what we have created, because this 8/1/2020 7/1/2020 has to be ended with 7/31/2020, right? And this one has to be ended with 6/30/2020. So how we gonna take care of this? So we are using the window clause, a lead window clause. So what it will be doing, it will basically ordering it depending upon ordering on this effective date. Okay, and 1/1/2020, and then 7/1/2020, and basically in ascending order. Okay, and then it will be taking its leading column. Okay, its leading column will be 7/1/2020, and then its leading column will be 8/1/2020. It's and this and leading column for this one will be null. Okay, so now we are checking if there is a leading column, then take that leading column and do the subtract with one date. Okay, so it will come basically as effective end date will come basically as this, and effective date here will come as this, because it will take this date and subtract -1. Now if this is null, then do none and cast it as a date. Okay, so it will just be like that. And for the current logic, for the isCurrent logic, will check if this is null. If is null, okay, then mark it as a true, and otherwise mark it as a false. So this is a logic that we are using for the SCD2 in our case, and that goes for customer address, and product price. So these three are SCD2 tables in our case. So I'll just showcase this one. So now if we see this one here, so it will take the table and load timestamp. It will check. So this is the logic that I was telling, the merge one, that is the when the data is in. Okay, so this one is the first case where the record is in the target table. 1/1/2020 is in the target table, and the new record is coming with 7/1/2020. So what it will do, if it will like if this condition is met, like if this is true and this effective date, whatever source, what this one is coming in the source is greater than effective date in the target, then it will it will end the effective date with source effective date -1. So it will be ended with 6/30/2020, and its current will become false. And then I guess I didn't do this one, so let me do this. Okay, I'll run this from here. This one was done. Let me do it from here. So it is generating the surrogate key and the business key, and then this is deriving the additional column, and this one joining it with other dimension tables to get their surrogate key, and this one is to get the load timestamp to see if it is the full load. If it is full load, then delete the history too. And then this one is for merge one. If the data is there in the table, then merge one is completed. And then let's check if some data was something like that. There was no data like that. Okay, so all our new data, and because this is first time we are doing. Okay, and what it is doing basically the same. It is taking the window function, lead window function, and it is basically finding the next effective date in all the cases that we have already discussed. And then it is merging, inserting on merging. And the next one is to find, like, because we are saving it in the load table, how many rows are impacted. So here I'm just taking it from the metrics, the targeted rows inserted and updated, and adding them as a loaded count. Okay, so 4 rows were inserted because one was errored out, and let's read it from the dim customer. This is we read it from the dim customer, and this one is to insert in the controller table, so that next time it will basically treat it as it will basically tell that this is for the audit purpose, that it was loaded at this time. And this is from the load controller. And here in the last we are generating the symlink manifest for the AWS Athena to take these symlink manifest. And then we have also, I'll show you, we have also created that external table commands so that we can run it in AWS Athena, and then they can take our symlink format manifest file, and they can make this data available for reporting or ad hoc queries. So this one, so symlink manifest file is generated, and then I'll just show you this one. This one was our customer. So this is a customer, and this one is a symlink format manifest file that has been generated, and these are the records that have been generated in the dim customer. And going back here, so dim customer is done, and let's now move to dim customer address. So this is also the same concept SCD2 that we just did with the discussed for the customer. So again, let's just go through with this. The table will be dim customer address that will be generated here. It is reading from the silver. Okay, so it will read from the silver table. It will perform its DQ validations. And then we'll be generating the surrogate and business key. Here this one is done, and here the surrogate key is address ID, customer ID, store channel, and effective start date. This is SCD2. And the business key here, the address business key, address ID, customer, store channel, and we are taking a customer key with a customer ID store channel. We are hashing, we are using the hash key because we have to get it from, we have to basically join it with the dim customer to get the customer a surrogate key. So that's why we are just doing the customer binary key, because dim customer is having customer business key, because dim customer is also having a customer business key. So it is more faster to compare, it is more fast to compare the business compare the hash keys. So that's why we are generating the customer business key here too. And so the data validation completed. Table data count after DQ validations 4, and it was 4 only, so there are no errors. Okay, now here there is one more extra thing. So as we saw in the customer that one customer was errored out, right? So this customer was error out, customer 004. But now if we see, there is no problem with this address, right, or any of those addresses. Okay, particularly this address doesn't have any DQ failing, but we cannot add this address alone in the customer address, because it will act like a orphan record, because there is no customer associated with it. So for this we have introduce the DQ validation checks on joining, so that I'm gonna show how it's gonna work. So here what we are doing, we taking the gold customer table, the one that we generated last time, just few minutes ago. And so here we are taking and we are doing and joining it with the left NT. So what it will do, all the customers that are in this address data frame and not in the goal table, they will come out here. Okay, so df invalid will have those. So we'll just check if what is the count of those, if there are some of those. Okay, in our case there is one. Okay, what it will do, it will basically append it in the back table with the error description says customer not found in dim customer, along with it other details. Okay, and after that, once it has been written to that back table, the other 3 records, so the customer 004 should not go. So here if we see, the customer 004 should not go. So 3 records that will be left will be basically inserted, will be merged into the address table. So here we are joining it with the store code, channel code and customer business key to get their surrogate keys. And so let me do this. So here if we see the bad record count 1, customer 004, now it will not go forward with this, and then we'll read table and it will show the bad record that was created, the same thing. And it says the total records to be written in dim customer address will be 3, and these 3 address will be written there, and this is a bad table record. And now if it is a full load, then we'll just delete and delete the history also of the delta table. And then the same logic for the merge one, if the data is in there in the target table, means goal table, and then just put the effective end date with a -1 if that the date greater than. Okay, so it will be subtracted with the bigger date that is coming -1. Okay, so and it will make the current as false for the target table. And other than that, there is another merge that will basically insert when there are no records found for the new effective date that is coming. This is the same case that we have discussed earlier, so it will be merging. So let me start doing it. it says merge one completed. Let's see if any rows. There were no rows where the update was, because it is a new load. It's just first time, so there are no records in the target table, so that will not be triggered. And then here again we are creating the window clause, the lead window clause and window column, and then here we'll be inserting it, and then we'll check the loaded count. It says merge to completed, and it has to be 3 and it is inserted. Okay, there was no update, so number of records inserted, because this is when not matched insert. Okay, and then we'll be loading it to the load controller, and then we'll be just checking what the load controller got, 3 on merge, and then we'll be reading and creating the symlink manifest file. So now if you go here and goal TB, so this one was our team customer and symlink manifest got created, and here are the files. It is a delta table, delta log is there. And now let's start the Spark. Okay, now next one that we will do is the product table. I'm going to show this because this is a SCD one. This is different. The earlier one is SCD2. So in SCD1, let me just go. These are the same thing that we have done. Reading the silver table and then doing the DQ checks, DQ validations, and then adding the audit columns, and then checking it for the full load, then truncate the table, and deleting the history, so no time travel allowed after that. So table data after DQ validation 3, no error, otherwise error would have shown here. And okay, so scd1 basically we don't want to maintain any history, so this is a simple on merge. If the product ID, so here product ID is the business key or surrogate key we could say. Okay, here in this case both are same, so product ID will be matching on a product ID with the source, the file basically, and the target, that is a goal table. If it is matching, okay, then we'll do update. If it is not matching, then we'll insert all. This is simple scd1 case. And then we are checking here the operation metric. So merge is completed. Let's check. So 3 number of rows inserted, and then inserting it to the load controller, and then creating the symlink manifest file. And here we go. Dim product, the symlink manifest file has been created, and this is the data. Okay, and then next one is the product price. This is again SCD2, so this is working same like a customer and customer address. So I'll just go and run this. So this one is a product price. This is SCD2, so this will work same like a customer and customer address logic that we talked about, with the same logic for the merge also. So it is checking for the DQ validations, and then we are taking so there are no DQ validations. Then we are creating the hashed business key and the surrogated key. So business key is product ID store channel, and surrogate is with the additional effective start date. And then here we are joining it with other dimension table to get their surrogate keys. And then here we have the same logic that we talked about earlier. If the data exists, if a record exists in the target table, the goal table, then it will be matched update. For if that is having effective date lesser than the one that is coming in the file, and that will be effective with the effective end date will be the one coming with the file in a file with n-1. And now this one is the history, because this is the first time, so there will be no updates. And next we'll doing the lead window clause to basically identify what will be the effective end date for the other records that are coming in. It says merge to completed, and let's check 3 records were created, and this will write to load controller, and we'll check the load controller table, and we'll create the Symlink manifest file. And if we go here, and refresh, and then check the product price, this is everything got created here. And then let's go back here, and the next one we have is the fact orders table. So these are fact tables. They are basically kind of treated as SCD1, because here we don't retain any history. So these are simple loading tables. Let me show you. This is same. We'll read the table from the silver table to the DQ validations, and adding the audit columns, and then we'll be reading basically getting the surrogate keys from other dimension tables. And here, because there is a customer business key involved, so we'll again do the joining with the left NT join, so that that customer cause 004 right now it is not here, so it will be fine. But if the customer 004 would have been here, then it would have been taken out and added into bad table. And then we are just joining it with the other tables and getting the surrogate keys. So here bad record is 0, there are no bad records. And here we are joining it with store channel and order date and ship date with the dim date, and the customer for the dim customer and dim currency. And then here we have to insert 2 of the records will be inserted, and here we are deriving the additional column like a total price, net revenue, gross revenue. So net revenue depending upon if the shipping paid by customer. If shipping is paid by customer, then the net revenue is our total price what we have paid. Otherwise, if shipping we have to pay the shipping, then the net revenue will have that shipping amount need to be deducted from our total price, because that cost we have to incur. So that is the logic we have used here. So we were here, so the merge was completed, and then we saw the two records were inserted, and this is when we read the table, this is what we got inserted. If you see here, then it has a order ID, line number, and the order date that is coming as a surrogate key from the dim date, and similarly stores surrogate key and channel currency we all have. So earlier it was, those were values, but now we have a surrogate keys here, and along with that here the gross revenue, net revenue, those got here, those are populating here. These were the derived columns, and so this one is a fact orders, and the next one we have a controller. We loaded it to controller, data written to the load controller, and here, and then we are generating the manifest file. So if you go to fact orders, so here the fact orders is here. The symlink format manifest has been created along with the Spark file, and then let's go back. The next one we have is the fact inventory. Fact inventory is again the fact table. This is for snapshot. This is capturing the snapshots of inventory daily for each product, per channel, per store, for that for each day. So here we'll start here. It's same. The table will be gold fact inventory. Here we are reading from the silver table, and then we are doing the DQ validations. After that we'll be appending audit columns, and along with that we are generating a surrogate key, inventory surrogate key, with the inventory date, product ID, store, and channel as a surrogate key, and this will be big int, so we are using XX#64. And table data after DQ validation 6, there are no DQ validations reported. Silver data count was also 6, and now we are joining it with other dimension table to get their surrogate keys. So we are joining it with the channel, date, and currency, and store date for the inventory date. So right now inventory date is 2025-0101. It will be without hyphens there, and similarly the store channel are string Amazon US and marketing platform, so they'll be replaced with the surrogate keys including this currency. So like here the store surrogate key is 211, and then this one, and the inventory date, this has been, the hyphens in between are removed, so this is done. And the next one is we are deriving the additional column, quantity on hand change. So this one, for this one we have to see what was the quantity on hand yesterday. So what we have done is use the windows window partition window clause lag. Here what we are doing, basically we'll see what was we'll take the inventory date, order by inventory date, and we'll see the product ID, store, and the channel key. We'll be partitioning on that, and then we'll be creating one more column, quantity on hand yesterday. and then we'll see if the quantity, if there is no lag, if there is null coming, no lag column to that. So basically, so say suppose yesterday we were having 10 inventory and today we are having 20. Okay, so the lag for this will be 10 and this one will be null. So what we'll do here, the quantity will be as it is 10 because we'll treat it as a 0 as per the logic, and here it will be 20 minus 10. So this is what logic is doing. So if I go back to the logic, so this is what it's doing. It is finding the lag and doing the inventory by date as a ascending, and then if the lag, if there is no lag column quantity, there was no hand quantity on yesterday, then it will basically take the quantity on hand as it is. Otherwise it will take quantity it will take 0, otherwise it will take quantity on hand minus quantity on hand yesterday, and it will show you 10, and here it will show 0 because there was no change. And then we'll be having we'll be checking the maximum load time stem, and we'll check if this is for the full load, then we'll truncate the table and delete all the history also from the DT delta table. And then this will be acted as a SCD1 because this is no, we are not retaining any histories for the fact table, they come as is. So if the surrogate keys are matching, it qualifies for an update, and it gonna update cost, price, quantity on hand and all these columns, and if it is not matching, then insert all. Then it will see how many rows inserted and updated just to get the loaded count, so that we can put it in a controller table. So 6 were inserted, so total number of counts, loaded count will be 6. And this is the table that was loaded, and this is a Spark, this is a load controller that will be loaded here. In here insert control logs will call that. And now we are generating the symlink manifest file. And if you see here, gold fact inventory, here the fact inventory and symlink manifest file along with the Parquet data and the delta logs have been created here. So next I'll stop this part. So this was fact inventory, and the next one we have is fact ads performance. This is about the campaign data for each channel and each store for that day, so it is per day. So here again we are reading it from the silver table, and then we are doing the data quality checks, and then adding the audit columns. So DQ, and then we are generating the surrogate key here. The surrogate key here is the add surrogate key, that is campaign ID, add date for that particular day like every day, and then store, and then channel, and then DQ validation completed, data validation count 1. So there are no data quality errors, and then silver data count was 1 only. Now it will join with other dimension tables to get their surrogate keys before loading. And then it will again take the maximum load timestamp to see if it is a full load. If it is a full load, then truncate the table, and vacuuming it is 0 means deleting all the history, so there could not be time travel. And then we'll be merging, so this is again kind of a SCD1 case, where if it is the surrogates are matched, surrogate keys are matching, then it will qualify for update. Otherwise it will do insert all. And then let's see what got inserted, because this is a new the first time load. This is inserted, there are no update columns. And then this is a read table. This will be read like that. These are the surrogate keys that came after joining with the dimension tables. And then this is inserting the control log in the load controller. And we'll be checking the load controller data, and then we'll be creating the Simling manifest file. So if I go to factad's performance, here factad's performance, and here we see the data is generated, and then we'll stop it. Okay, and now the last one is fact customer event. As we know, this was the JSON file that was coming in, and this fact customer events, basically what here we are doing, it is, there is no update in that, because this is events. So whatever customer is doing action on the product, will just take them as is and put it it's only insert, it's only appending case. So here I'll show you, this one is a fact table 2. And because this is involved with customers, so we'll be doing that another set of DQ validation for the customer. Like if the DQs on the data quality checks on joining with the customer table, because if there are no customers, then there are no customers added to the customer table. We don't want the data for that customer to go into the customer event table. So simply, if that is the case, we'll just put them into the bad table, and otherwise we'll join it with other dimension tables to get their surrogate keys and load it. So data validation, the DQ validation generally the general DQ validation that we are doing on table, there are no DQ validations for that one, and that we are appending it. And then surrogating key and business keys are getting evolved. Here we are taking again the big int, so XX hash 64 we are using. We are doing the hash surrogate keys for better performance on joining. And then now here we are checking if there are any invalid customers that were not there in customer and customer table, but if they are here in the customer event. So we found the bad record count 2 were found because there were that is related to this customer. So here this customer 004 is having that problem that was coming here, and then total record count to be written will be 5, total was 7. And now so these two records are in the bad table. And the next one is to see again the maximum load timestamp. If it is full load, then truncate, and then doing this merge. And in this, as I said, there are no update cases, because whatever is coming on our way, we have to just put it like that, and there is nothing to update. These are the events basically, so we have to capture all the events. So when not matched, insert all. And then we'll check the loaded count, how many were loaded, supposed to be 5 here. And then we are reading table, this shows like this, and writing it to the controller table, and we'll check the controller table and generate the Simling manifest file here. And then if we go here to the fact customer event, So here the data has been generated, and then stop. So this was so with this we have done with our gold layer also. So the data was loaded first to bronze, then to silver, and now to gold, and is available in here in S3 bucket too. And and here is the last thing that I want to share is the script that we have prepared. So as we have seen, we are done with our loading at bronze, silver, and gold layers. So this is the last thing that I want to show. This is a script that I have created to basically to create the external tables, symlink external tables that we can run at AWS Glue Hive Metastore. That in turn, when the AWS Athena will query the tables, so they're gonna basically get the data for their analytics and ad hoc queries. So here what the script is doing, it is basically opening a Spark session, and the symlink path I have given is for the S3, AWS S3, and what it is doing, it is basically creating for all the tables that were in a gold. So we just did show tables in gold. The schema is gold here. So all the tables will come here. We'll be taking one by one each table, and we'll be taking its type, the column name and the type, and there we are basically joining it and printing this statement. So I'll show you this. So if you see here, the external tables, the DDL for external table got created here. We can take this, copy paste, and execute it in the AWS Glue Hive Metastore. So what actually it is doing, it is creating external table for the Hive, and this is a table name. Okay, what it gonna create, and this one basically are the columns, and raw format serial deserializer in the Parquet Hives for Surday. What is it telling? Basically it is telling that deserialize the file in a Parquet format, and the other line stored as input format in a symlink text input format. It what it tells is that it tells basically to treat the file as a symlink. So symlink basically will be the text that we will be reading from the symlink file will be actually the not the actual Parquet files, but there'll be the path to the actual Parquet files. So it tells that when you open the file, take that Parquet and treat it as a path to the actual Parquet file. So this means that symlink text input format, and output format, basically this is ignore the key while writing. This doesn't actually go with our this case. It is just syntactically that we have to put it in here, and the location basically from where the symlink manifest file is actually located, and TBL properties table type equal to symlink. This tells that this is not the normal external file external table, but this is a symlink external table, and we need this. Actually this is like a mandatory for when we use this stored as an input format as a symlink text input format. So this will basically create it, and as I said that we can take the scripts and execute in AWS Glue Hive Meta Store. So it will create those external tables, and when the AWS Ethna will come and say, suppose it will do select star from this table. So what actually it does in the back side of it basically stores as a metadata, not the actual data in the external table. So AWS Ethna when will do the query on this table, then it will start deserializing the file coming as a Parquet format, and it will read the file from this link and treat it as a symlink file, because so now it knows that that file actually is not the actual data, but it is a path to the actual Parquet file. It goes to that Parquet file with this location, and it will basically start pulling the records from there. And the last thing I forgot to tell, like show my configurations that were needed for to connect my Docker with the S3, AWS S3. So the first one is we'll go to the root and basically we'll do .aws and then it's a folder not directory we'll create and then we'll open credential, and in credential we'll put our AWS access key and the secret access key. And similarly we have the Hive site XML. In Hive site XML, if we want to connect it just to the local, here Hive Metastore warehouse dir, we have to give this value as the local one. But if you want to connect it with the S3, you have to give it uh, till warehouse, the path for the S3 till warehouse folder. And again in the Spark default dot configuration file, will come here in and we'll add this Spark SQL dot warehouse directory, and we have to give here the path for the S3 data lake. So that is all for this project. Thank you.